I'm a quite recent addition to the OTP team. I've been working there since September, and before that I was writing network configuration software at Cisco for almost 7 years. And there might be one or two in the audience that actually had me in some very, very old lectures long time ago. I hope that's forgiven by now. So this talk is, as Stavros said, it's going to be about evolving Erlang feature by feature. And well, some kind of introduction then to the talk. Oh, this was actually going to be the last question, so we can start with this. So we're going to change OTP, but slowly in a controlled way. And of course, will this make it better or worse in the long run? Well, easy answer, yes, it will. And that's all I'm going to say about that. We had a new release of OTP just 2 days ago, and this is part of it. And there's a sort of giveaway, because this is the implementation of the Erlang extension proposal number 60. So quite a short turnaround time from writing it to actually getting it in there, but I guess being at the OTP team made it somewhat easier to get there. So what is it we want to do? Well, we want to introduce a way of making controlled and careful changes to Erlang, especially the language, but also the runtime as such. We also want to increase and have the possibility to try out and give and get feedback to changes before they're made permanent. Today, this is a bit more cumbersome process because somebody proposing a change will do a write-up in a EEP and hopefully also give some kind of prototype implementation. Could be full implementation, it could be just shelled out a bit. But anyway, anybody who wants to test it will have to get that branch. It might be based on an older release or whatnot. So it's not really that easy to test it fully. Here we want the possibility to test these things in a otherwise stable release. And also, when there are changes to a CodeBase, to OTP, we want to make the possibility to allow the adoption of the CodeBase in a slower way, in a bit more paced way, when you have the time to do it instead of being forced to do it. So a quick overview is, well, some kind of motivation for this, details, examples of actually using it, and also an example of another newly introduced EEP, that is EEP 49. Kenneth mentioned it yesterday. It's the maybe expression, so that's our first feature with using this support, so I'll talk about that a bit. And then give some final implementational details and some words of what this is and what it is not. So in terms of motivation then, well, what's the problem we want to solve? Well, I mentioned the issue of being able to test changes before they are made permanent. And there are some changes made to OTP from time to time. They're not that many, but they do happen, and not all changes are backwards compatible. So if a change happens and it's not backwards compatible, and one thing being if new keywords are introduced, if you're using these keywords as atoms in your current code base, well, sorry, you have to fix it, and you have to fix it fully before being able to run and release with this new release. So this means that changes are in some way sort of forced upon a code base when there's a new release. And having worked with some quite large code bases, upgrading or adapting to a new OTP release, it's not really that straightforward. And especially, and I guess this is true for almost everyone, you will have your own set of patches as well to OTP for various reasons, because your special use case will go faster if you tweak some bits here and there, but you might not find it really feasible, or you really don't want to do the work and try to get the changes upstream. And these changes can take a lot of time, even if there are no syntactic changes, because it changes to libraries, and you have to sort of go through a long run of tests before actually being sure enough that okay, we can release again, or we can release with this new OTP release. And sometimes that will mean you will lag a bit in terms of releases. And then, as I said, the proposed changes from EEPs, they're not always easy to test. Check out a branch. There might be other changes on the branch. It might have some old bugs in there which you don't want, etc. And that makes the somewhat lack of feedback. You might not get some kind of technical problem. Okay. So process suspended for a bit, but I guess I can continue. So I think it was on the feedback. Ideally, you want to get feedback from a large part of the community trying out your changes, and not just reading a sort of theoretical proposal and thinking hard. For some people and a lot of people, it's much easier to actually get a feel for it if you can test it in action. And especially if you can do it sort of with your full code base and run it. So these are sort of the problems we want to change, we want to solve with this. I was hoping, yep. And the solution is that we want to make it possible to configure the use of changes. So there will be changes in there, and in this instance, when we talk about changes, we're mainly concerned with language changes, runtime changes, but not things like libraries. Although this mechanism could be used to take care of changes, actual changes in libraries as well. So we will make it possible to, and it is possible to try these out, try these changes out in a stable and official release, because it's part of the official OTP 25 release as it is. So it will be easier to both get and give feedback, because we're hopefully reaching a wider audience, regardless of if it's we or a contribution that's proposing a change. And when a feature is made sort of permanent, or a more permanent part of the language, it will still be possible to not use it. So you will not be forced to actually use it and adapt your code base until it's a really permanent part of OTP. So if the sort of outcome of testing and feedback, etc., is positive, it will eventually move to be a permanent part. But before that, you can either enable or disable a feature. So you can go slowly, and there's no sudden forced change with one release. Well, if you slack enough, of course, you will come to a point where there is a forced, because when we make it permanent, then there's no way to disable it. So we call this features. It has a more positive sound than just changes, but it's changes anyway. So what then is a feature? And some kind of very loose definition is its additions, changes, or deletions with a visible effect to syntax and semantics for users. So not so much as changes in standard libraries and APIs and stuff like that, but actually the language as such. Most of them, I would say, will probably affect syntax and semantics. Some might affect runtime. We haven't really thought up any runtime changing feature as of yet, but we might get there. We're just saying it might be there. And examples, and probably most common, are new syntactic constructions, like the maybe expression, and I will talk about that later. But we might change semantics of existing constructs to make the language better or worse, depending on how you see it and depending on your point of view of change, because, well, change is difficult and not always easily adapted to. So yes, it will make it better or worse in the long run, but yeah. And one nice feature of this is that language and semantics level changes can be made local to one module. So if you enable a feature, you can enable a feature just for one module, try it out in that module. And that also means that you can adapt your code base one module at a time. So again, you can do it in a slower and paced way, and not having to wait to rewrite 57 modules before you can actually test it. And of course, any runtime features, they will affect everything at runtime, because there it's much more difficult to say, well, only in this module we're going to have the runtime behave like this. I guess it could be possible, but let's not really go there. So some details of sort of the life cycle, almost sort of like a state machine for a feature. Well, it's experimental, so the formatting has changed in some transfer here. So a state change can only happen between releases. So we have what we have in OTP 25, and there can be changes, so there might be new features added in OTP 26. And the state of the current feature, that is the maybe expression, might change to when we come to OTP 26. So essentially, every feature will start out as an experimental feature, and that's where you want to make it possible for users to try and get feedback. And details of this feature this construction can still change when it's not in that state. So after that, it's essentially three ways it can go. there's a really bad path saying, okay, this was really a bad idea. So we just put it in rejected directly. Then it can go to approved, saying, okay, this is a middle state. This is what we want, but we're still making it possible to adapt slow to it. And this is probably the most common case path, that is from experimental to approved and then to permanent. I guess we could go directly from experimental to permanent, but that will force a change directly. So in these different states, I had a much nicer typeface there, to be honest. In these different states, a feature can be it can be configurable, and in the experimental state, it is, and that means you can enable it if you want to use it, and the default is that it's disabled. When we move to the approved state, we're saying, okay, this is eventually going to be a part of OTP, so it's still configurable, but the default is that it's enabled. So it's sort of a soft permanent. It's saying, okay, the default is that, yeah, well, it's there, but if you don't want to use it, you can disable it. So again, an opportunity to do a slow-paced adaptation of your code base. And then, of course, well, you come into the permanent state, and when it's permanent, no, you can't configure it anymore. You can't disable it. You're forced to change, and yes, it's enabled by default. And well, the rejected state, that's very much like not being there at all. It's you can't enable it, you can't disable it. It's just not there anymore. But it will be there in terms of at least the feature history. But we'll probably remove the supporting code for it. If it's rejected, well, we don't want the dead code either, so let's bring out the dead and be done with it. Then there's also another aspect. I'll get back to that a bit later, but mention it now. And that's the state of or the property for a feature of being available. And in all states but rejected, we're saying that, okay, this feature is available. And available means that it's known, so the system knows about it, and we can use it somehow. We don't have the information if it's on or off by default directly. We can get that information. But being available is something you might want to use when you write code that can adapt to features being available or not. And maybe you want to, well, if it's available, then I want to enable it. So let's look a bit at some feature support in action. So there are some new options to ErlC. I went bold here and actually made somewhat long options. So you can ask ErlC about available features, so list features. And well, today there is exactly one feature available. So you can get a short description of it like this. The name, a short description that this is value-based error handling, EP49. And then you get the state that it's experimental and experimental from OTP 25. And if you're still stuck in the shell, you can get a bit more information as well. So you can describe a single feature with a describe feature. So again, you get a short description, and here you get a bit more information saying, okay, this is an extension. Another alternative is that it's a backward incompatible change. So of course, in some sense, this is backwards incompatible because we're adding, as we see, two keywords, maybe and else. And that means any use of maybe and else in your code base as atoms will have to change. And then, so this is our one and only feature, and it's just been there. The status, you will actually get, in the long run, a history. So if it's approved, it might say approved 26 and experimental in 25. So you can actually see the history of the feature. And then there is a somewhat longer description, but not too long. And these new keywords will of course affect existing code. And these maybe and else, before you enable it, they'll just behave like ordinary atoms. It's only when you enable the feature that something happens. So given a very simple module, which just exports a function with returning a list of atoms, but in there we have the maybe and else atom. So this is going to be a danger. But we can, well, if you just compile it as normal, nothing happens. Fine. But it might be a good idea to look through your code base in the existence of features and know about, will I have any problems if I enable it? So if you use the plus warn keywords to ErlC, it will tell you, okay, you're using the atom maybe, and it's reserved in the experimental feature maybe exper. So this is a nice way of just looking through your existing code base and seeing if you have any problems in it. So that's hopefully useful. And then we can also start with enabling this feature and see what happens. Because we have these atoms that are keywords. So, well, as we know, if you use them like that, so we enable the feature and try to compile, there will be more errors as well, of course, but we're getting a syntax error before the comma. That is because the maybe expression isn't complete. So no surprise. It saying, well, wouldn't it be possible to say, well, this maybe is incomplete and mention something about it being a feature? Well, of course it would be possible, but that would lead to quite large changes in the parser and the error handling. And very much on a feature-to-feature basis. So this is, well, at least you know something is wrong. And especially if you know about the warn keywords, you can use that. So let's fix this. So we use we have a Q simple for quoted, so we quoted our atoms. And now the results are positively boring because everything just works. For the ones who have actually already downloaded and are running OTP 25 and try this example, you will not see this exact behavior because the warn keywords in OTP 25 will actually still warn about quoted atoms, but it's fixed in a later branch, so it will be there soon. So, first step of adapting your code base is quoting any atoms that will be keywords. So we have our first feature, which is the maybe expression. Kenneth mentioned it yesterday in his talk, so it's in there and you can use it. And it is in the experimental state. So try it, give feedback. Do you like it? Don't you like it? Could it be made better? So this is EP49 called Value-Based Error Handling proposal, initial proposal by Fred Heber. And as you've probably seen, there were a lot of discussions back and forth, so there's a lot of contributions from others as well. And one way to see it is that it's a localized and more detailed error mechanism. So it introduces this new maybe else end expression where the else and the match clauses are optional. So the code would look something like this. Maybe, and then you have a sequence of code, and then possibly a else before the end, which with a number of match clauses. And the semantics, well, yes, it introduces this new conditional match operator written question equals. And it's only available, this question equals, the conditional match operator is only available at the top level of a maybe expression. So you can't have it deeper inside because it's very local here. And everything else you write, so you don't need to have only this conditional match. You can have ordinary matches and whatnot. So everything else inside the code block behaves as usual. But if a conditional match fails, then the rest of the code is skipped. And if the else is present, the right-hand side, that is the value of the failed match, will be matched against the patterns, and the corresponding expression will be run. And if there is no else present, it will return the value of the expression that didn't match, and it will otherwise just return the last expression. And then there are some details regarding scoping, but the simple answer to scoping here is that any variables you bind inside either the code or the pattern or the match clauses are not available outside. And the explanation for this is, well, you don't know how far you actually run your code. So there's no guarantee as to how many of these variables are actually bound. So the easy way is saying none. And that's really proper scoping, really. So a simple example, it doesn't really do anything. It's just a way of showing what's done. And if we compile this code without enabling the feature, well, of course, it doesn't work. And then you get a new syntax error because it's incomplete. Well, you have a maybe that you have an expression that isn't recognized because the maybe is not recognized as a keyword because it's not enabled. So we can enable it with the enable feature, and then we want to run the code. Oh, sorry. Just another example. We can enable the feature with this expression as well. That is the format for using a plus expression to ErlC. But being a tuple, you have to quote it, and it's a bit more cumbersome, but you can do it. And here's an additional way of enabling the maybe feature. There's a directive inside, you can use inside a module. So feature and then the maybe expression and then enable or disable if you want to. And for those of you who were at Kenneth's talk yesterday and remembered everything, you'll say, well, isn't this a bit strange? Because Kenneth had the feature directive after the export. I'm not going to say that Kenneth didn't test his code, but that's probably the case. Because that doesn't work. The feature expression directive has to be, well, and the error message now is a bit lame, but it has to be before anything interesting happens. And that is before anything that actually uses syntax happens. So since export uses syntax, it has to be before the export. You can do stuff like define macros before it. You can use macros. You can use includes, as long as this holds. So there's a restriction on the use of the feature directive that it has to be in a prefix of the module, but also a prefix sort of include files and stuff like that. You can do some really horrible stuff with include files, like your first statement can actually be an include, and you define the module name in your include file. I don't know why you would want to do it, but it's possible. Well, I can actually think of reasons, but let's not go there. But this is a good way of enabling the feature, and this is definitely, I'd say, also the preferred way of doing it, because it's most local. Because here you're saying, in this module, I want to enable the maybe expression. So you can look at the header of your module and see what features are enabled or disabled, because that's possible as well. So if we compile it, yes, everything is fine, and then we want to load it. And it crashes. Well, you get an error saying, well, this isn't allowed, because the maybe expression is not allowed. And we can actually call the supporting module Erl features and ask about the set of currently enabled features, and we see, oh, there are none. But if we instead start the runtime system with the flag enabled feature and the maybe expression, yes, we can load it, and yes, we see that the maybe expression is enabled. There is some discussion of if you really want it this way, but the current state is that you have to enable the feature in the runtime as well to be able to load modules that are using a feature. And we have done it like this because we want to at least make it possible for a runtime system or production system saying, well, it's fine that we test this stuff, but we don't want it in production yet. So this is a way of saying, well, you have to enable it to have it allowed in the runtime. Also, a bit of note on the feature directive. In earlier development, this was actually allowed anywhere in the module, but that was considered, well, for one thing, the code was very complex. It was sort of yucky, really. But it would also make the reading of any code much more difficult, because you might drop in and out features and not even overlapping and stuff like that. I got it to work, but I don't know if it was really useful. So, short summary then of enabling and disabling features. There's options to ErlC. You can use the 3-tuple, either to ErlC or to options as to functions in the compile module. And there's the feature directive, and the feature directive is definitely the most preferred one to use. The documentation also mentions that you can use it in a compile attribute. I don't think that works anymore due to having removed the possibility to have the feature directive anywhere. This is one thing I realized when writing these slides. So yeah, I have a somewhat of a to-do list there. And then there's the warn keywords, which is off by default. And then we, have the enabling. So how much more time do I have? 5 minutes? Yeah, okay, that should be usable, doable. So the effects on the code base then. In different states, well, the effect, if you're in the experimental state, there's no action. You can use the warn keywords if you get some early warnings, and you have to enable it if you want to use it. In the approved state, since it's on by default, new keywords, for example, will cause errors, but you can disable it to avoid any adaptation. And in the permanent state, well, now it's time to adapt. You can't disable it anymore. And in the rejected state, well, nothing to do. So back to the availability. There's also an addition of two preprocessor macros, feature available. So this will answer true for any known and non-rejected feature, and false otherwise. And then there's the feature enabled, where you can ask if a feature is actually enabled, so you can use it for conditional compilation, where you might have two variants of your code base. So typical use would be something like this, and we see here that we can use the feature available macro and enable the maybe expression if it is available. But if it did become rejected, so it disappears in OTP 26, but you have your code base, if you write your code like this, then you're still safe. There's also a informational model called Erl features, and this contains supporting code, mostly for internal use. But it's and it's used by the tokenizer and compiler, etc., when asking for example, for reserved words. But there are some useful public functions as well in it, where you can ask about the known features, you can get information about the feature. As we saw, it's actually enabled 0 there, where you can ask about the features which are enabled at runtime. Maybe not that useful, but it can be used. And you can also, for a module, loaded or not, ask about which features it's actually using. Yeah, I said this. Well, we can't change the set of enabled or disabled features during runtime. It was possible in RC3, I think, but it's gone now. Because that would lead to an inconsistency. If you first have a feature enabled and then disable it, you might have modules loaded with the feature enabled. So what about the details then? So implementing a feature, and for us, I mean the OTP team, and the users, well, that's you guys. So that's the nice thing about working at the OTP team. Our users are very technical, which is nice. So we see that, well, for example, the maybe expression, it introduces these maybe and else keywords. So this will affect tokenization. And it will affect output, because at output we have to know that, well, this is a keyword, so it has to be quoted if it's used normally. And also else is also used in the preprocessor, in the -else construct. So there's some trickery needed to go into that as well. And then we have the potential effect to any existing code base. And then there's the new operator for the conditional match, and that will again affect tokenization, but not too much more. There's a need when implementing this, we need to add a new grammar rule or some that makes use of the new keywords, and it affects the parser. And then, of course, at some level, there's changes to the compiler, the shell recognizing stuff, etc., etc. So implementing something new does affect quite a lot of code. And in this case, there's no change to the runtime because it's all done in the compiler. And then, on top of that, we have to make it possible to switch on and off, making it a bit more complex for us to implement a feature because it has to be there and not. So just sort of a short foray into implementational details. A conservative extension to the grammar, which this is, the maybe else expression, it's fine. So in the grammar, it's still there, even for normal use. But since the enabling of the feature will affect the tokenization, so maybe an else will be keywords, and that will trigger the rules in the parser, but they're still there. If you want to introduce things which affects new existing keywords, then it will definitely be more difficult. There is some quite general support right now for adding new keywords, which is used, affects tokenization and input. And also, so we saw that we can't load a module if we don't allow it in the runtime. So the compiler will add information in a new chunk regarding which features are used at compile time. And it's the intent that is recorded, not actual use. So if you say enable feature and compile it, even if it doesn't use the feature, it's still there in the chunk because it's recording the intent. So some of the drawbacks then. Well, of course, this means that there's an increased maintenance burdens for us in the OTP team because it's general feature support. We have more code for that. We have the conditional support for each feature. So for us, there's probably a desire to keep the number of features sort of quite low to avoid feature interaction, to avoid making the code base too complex, and to avoid too many knobs. But of course, for you as the users, there's also an increased burden because there might be conditional code, and you need to know about and understand these new and different features. And of course, here's also an interesting thing. We can't actually use these new features before they're made permanent, because if we did, it would be recorded in the chunk, and then they wouldn't be allowed to load it. We could do some trickery to get around that, but we'll see. Also, a short rundown of what this is not. And hopefully a time for one quick question. So this is not a general mechanism for making it easy to add new features. It's still quite complex. This is not a safeguard against using these new constructs without it being recorded. If you're doing stuff on the language implementation level, compiling to Erlang, abstract syntax, and compiling that, then it's all bets are off. We won't see it, probably. So this is definitely, it's a high-level mechanism for normal users. And it won't really make it simpler to implement an EP, quite the contrary, because again, you have to add the support for the conditionals. And of course, well, it's not fully tested yet, so it should be considered as an experimental feature in itself, but I didn't really find a good way of making it possible to enable it. So, thank you. Questions?
Thank you very much, Cons. I'll ask a question on behalf of the audience. So the most popular one in the question list was, will this be available for changing the preprocessor, changing syntax, changing all of these things? And I think you answered this already in some ways.
Can you say
will the experimental features allow changes in the preprocessor, in the way preprocessor does things, in the way, or introduce new syntax?
Yeah, because it's not a general mechanism in any way. So if you want to do a change in the preprocessor, yes, do it and make it conditionable. And so, yes.
There are more questions in the Who app, so please go there and take a quick look. Thank you very much again for the talk.
Yep, thank you.